There we go. Okay. Present this. Show the screen. Okay. Here we go. So we're going to do two things today. The first part is board testing. So that is the most important thing we're doing today. And then, oh, that doesn't work. Okay. So if you're not done soldering, I think everyone here is done soldering. If you're not, just speak up now or put it in the chat. But I think everyone here is done. And just had, yep, and everyone here, I believe, has had their board checked. So we don't have to worry about that. I was going to have them go in a separate group with Ben, but I think everyone's done. Okay. And then, so then we're going to go right on to, oh, someone else joined. Yep, I don't think anyone joined who hadn't done, nope, okay. And then we're gonna go on to testing, and then we're gonna do some quick overview of how programming in Arduino works. I don't know how much anyone knows, so I will show some basic stuff and provide some links to other things if people need more information. I'll specifically talk about some of the features that Arduinos have that are a little different than what normal, like other programming you might have done has been. And then we have a task at the end. So we'll see how well that task goes. I got it to kind of work, which is what I'm expecting you guys to get it to do. So, oh, the arrows don't work here. Okay, so board testing. So the first thing that we should do, I'm going to, I want to see everyone's video. There we go, that's better. Yes, okay, so get your board out and get your USB cable out. And if you feel comfortable, I think we checked, Ben, we've checked all of the boards of the people in here, I believe, right?
Yeah.
Okay.
Everyone that sent their boards in Discord were good. Just like
that. Trey, did we check yours? I don't remember. It's the only one I'm not sure of.
Yeah, you did.
Okay, cool. Yep, so plug it in. Let's see what happens.
Nothing's going to light up because I didn't program Blinky, so.
Oh, you didn't program Blink on these?
No, I didn't have
You know, something blinked for me for a moment. I'm not sure.
Okay, never mind. So it won't blink like I thought it would, but oh well.
So if you have the Arduino IDE, you can just program it with something.
Yeah, so that's what I'm going to go through next.
Everyone has the jumpers on the VUSB, right?
We might not.
Oh, no. Yeah.
Oh, Matt's does have Blinky on it.
Well, no, I kind of cheated.
Matt, do you have the jumper on the VUSB pin?
Yes.
Okay. So can you guys see my mouse on the screen that I'm sharing right now?
Yeah.
Okay. So you see where my mouse is right now, where it says VUSB?
Yeah.
So you need to jumper the middle pin in that 3 with the VUSB pin, which will make sure that the power is coming from the USB port, which is what we're using right now. This is actually, I think, the biggest improvement that our board has over a normal Arduino is we actually have this little jumper, because I've probably fried 10 Arduinos in my life from just this one little problem. And then you should have little jumpers that look like this in your bag, and you want to put one of these. So they're little black with like a little piece of wire at the top, and you want to put one of those in between the middle pin and the USB pin.
When you plug it in, hold your finger over the middle of the AT mega chip, and if it starts getting hot, unplug it right away. The tried and true. Did you fry it? Check.
Wait, sorry. It's this piece? I'm sorry.
It's like a little
Little
rectangle.
black with a. Yep, that's it.
Okay,
You got it.
cool. And how
Sorry,
do we
what's
put
supposed
it
to get hot?
No, it's
Nothing
not
is
supposed to get hot.
Yeah.
So that's a little jumper, and that should go on the VUSB pin and then the pin next to it. So it shorts those two pins together. I accidentally ordered 200 of those when we needed 25 of those.
Let's go.
Which way do we put on the pins?
So there should be a little side with a little wire, and it should be the opposite side of that. There should be like a little hole in the bottom of it, and the little hole goes between those two pins.
Okay, thank you.
I was blinking for a second there.
Yeah, if we put it in, it blinks once. Do we then put it back on again, or do we keep it on or take it off?
It blinks once. I think that probably means it's good.
That just means the bootloader's on it.
Yeah, my computer made a noise, like it recognized it.
Awesome.
good.
These are
Thanks,
all
Chime.
good things.
But to clarify, we don't need to keep the jumper on it.
No, you need to
You
just
do.
leave the jumper on.
Oh, okay.
You don't need to take it off.
Wait, which one is the jumper?
So yeah, that little black thing that you just showed, Ethan, that needs to go between. I'm
The thing
circling
with
it on the
that-
screen.
It's like mostly like black plastic, but then there's like a wire.
Yep. So the opposite end of the wire connects these two pins together. VUSB, and then the one in the middle, right in the middle of your board.
Is there a front and back of it, or no?
No, it doesn't matter which direction.
Okay, so I plug that in, and then just hope this doesn't blow up. Oh,
Wait, so is it supposed to be blinking right now or not doing anything?
It might be blinking. Some of them have some of them have blinking on it, and some of them don't.
I blinked for like a second. And then
Okay.
it blinked once.
So what we're gonna do now is we're gonna make sure that you guys have the blinking software on it. So I believe you guys can see my screen.
okay. Nothing happened with mine.
Okay. So we're just gonna have everyone open up Arduino, and we'll program it to make sure. So open up Arduino, which is I have it on the wrong screen.
I can bring it to you.
I don't know if mine recognized. I don't think mine worked. Maybe.
Let me see if I can make the text bigger.
How do you put the jumper pin in?
It should snap on, basically.
No. That's Sundays.
I had a little difficulty getting mine
That
on.
club makes
but-
me apprehensive, and that's
Can
why I
someone
sit
send a
for
picture
2
of
hours
it?
not saying
I'm not
anything.
exactly sure how to put it on.
There we go. Yeah. Is anyone still having issues getting the jumper on, or are we all good?
I've plugged mine in. I just don't know if it worked.
Okay.
There it
Yeah.
goes.
So we're gonna program it now. And I actually have a board here, so I can kind of follow along. I don't know if you guys still get red boards, but this is my old red board. It had a piece of Velcro on the back for a very long time.
Does the type of USB cable matter, or like type of USB port?
No, it'll work on any USB port on your laptop.
Okay.
So then once you plug the board in into your laptop and you open up Arduino, I think you guys all have Arduino installed. I might have missed. The people who didn't go to the first meeting might not have Arduino installed. You can just Google Arduino IDE. Quinn.
Yeah, gotcha.
Okay. So what I'm going to walk you guys through is how to load the first program. So you go to File, Examples, Basics, and then Blink. And if you click on that, it will pull up the Blink program, which is right here, which should be on your screen now. And then with your board plugged in, what you should need to do is then go to Tools, Board, and click on Arduino Genino Uno. Right? John, these are Uno chips, right?
Yeah.
Thought so. Just wanted to make sure.
Generic Uno, okay?
Yep, generic Uno should be fine as well.
And then it's port, just the highest number. I have different ports now than I do with my SparkFun for some reason.
So that is going to be, so it might not end up being the right one, but like if you've used a SparkFun kit, this will be a different number than that. But it should just be like a higher number. If you
Okay.
have multiple, just go for the highest one because they're kind of ordered sequentially based on when you plug it in. So like mine is COM 3.
Sorry, what was the name of the board? Because I don't think I see it on here.
Arduino something Uno.
Yeah, mine
just
just
have
has Uno.
Yeah, I was gonna say I just have straight Arduino Uno, but
Oh,
Yeah.
okay. That's correct. I have an older version of the software. I think I need to update it.
And then do we just upload and hope for the best?
All right.
Yep.
I just got Arduino IDE open. What next?
Okay. So I'm just gonna give everyone the next step first, and then I'll
Okay, yeah.
get back to you on that. So
That
then
sounds-
there's a little arrow that says upload. If you click that, it should compile the program. So it's making sure that all of this works right, and then it uploads it onto the board. So then it starts, and then the board should just start immediately running, and your LED should be blinking.
Port COM 3 or COM 4?
I'd try COM 4 first. Whichever the highest COM number you have is first, and then like go down the list and try different ones if it doesn't.
Okay, it's blinking. COM 4 worked.
Okay, Quinn. So once you get into Arduino,
Yes.
go to File, and then Examples, and then Basics,
Blink.
and then Blink. Yep.
Okay.
And then go to Tools and Board, and click Arduino Uno,
Okay.
and then Port, and do whatever click whatever the highest number COM port is.
Board Arduino. Once I click for Arduino Uno, it doesn't bring me to anything about ports.
No, you should just go back to the last screen, and it should say.
Oh, port. Yeah,
Yeah.
and then whatever the highest one is.
Mm-hmm.
Okay.
And
then
then
just run.
click Upload, which is a little arrow below Edit.
My port button is grayed out.
Oh, you need drivers. Are you in Cornerstone or no?
Yes, I am, and my SparkFun red board works fine, but
Okay.
You shouldn't
so,
need drivers for this board because it uses an FTDI chip instead of the CH340, which I think is what the
Yeah, that
SparkFun kit
was
uses.
SparkFun drivers.
Okay, so Trey, you're just not seeing anything under serial ports?
yeah, the port button is just grayed out. It won't let me click on it.
First thing that I want to ask, if you hit the reset button, which is like the push button that you soldered on, does that blink the LED at all?
Yes.
Okay, that's a good thing. That means the bootloader's on there.
What are your guys' highest COM port?
Mine
I mean,
was 4.
Emma, is your code still uploading?
No, it just failed.
Oh,
We're getting hot, the chip.
No.
okay. What error did it give you?
Let's see, problem. My SparkFun codes get errored a lot, but they normally still work. This one says Sir_open can't open device. Problem uploading to board. And I've tried it on both comms and it errored out on both.
So try resetting your board. So just press the button on it,
Okay.
and then try uploading it again.
Yeah, it says problem uploading to board. Okay, let me try on the other comm channel too.
When you you can also check what COM channel it is if you like unplug it and see, and then plug it back in, and you should see like a new port kind of pop up. Like you can see which port.
All right.
comes in. You can also do it with like Device Manager. Sometimes it's easier to see that way. But like also just check like if you unplug it and then plug it back in, make sure it makes like a Windows noise, because if it's not making any kind of noise, then your computer isn't recognizing it.
I think it made a noise the first time.
I'm getting an error right now saying that the programmer is not responding.
Okay, so whose isn't working right now?
Mine isn't.
Fine.
Okay,
Yeah,
so
It's not either.
I'm looking into it.
so Quinn, Emma, Trey, and I think I heard one other person. David, yours isn't working either.
Yep.
Okay.
I think my problem is I'm pretty sure I broke the pin on the processor that goes to LED 1. So if I could just like know how to change it to a different one
Oh.
that's blinking, it'd be fine.
Yep. You can. So where it says LED built in here, John, do you remember what the second LED is off the top of your head?
No, off the top of my head. Where did you put the schematic?
Oh, I just have it on
It's
my
in the
desktop.
slides.
I'll just pull it up.
D7 or 7 or 8 should work. Number 7 or 8 should work.
After built-in or
Yeah, instead of built-in, you
Oh,
can
okay.
use LED, like the number 7.
I will try it.
Yep.
I just downloaded the Arduino software. Could you catch me up by any chance?
Yep. We'll go through it one more time.
Thanks.
Anybody whose board isn't working, try unplugging it, plugging it back in, and then tools. Make sure the programmer says, is AVR ISP Mark II correct, John? Make sure it says that under programmer.
Can you repeat that?
Yes. I should be on my screen right now, but it's AVR ISP MK and then two Roman numeral.
AVR ISP MKLL.
Yeah.
I just typed it in chat.
That might have been my issue. Nope, it's not my issue.
Sorry, I've been distracted. Is that for everyone or just those whose code isn't working?
Just for those whose isn't working, because
Thank you.
if it is working, then you probably already have that one.
Touche.
Okay. Yes, Ethan. So first what you need to do is open up Blink. So you go to File on Arduino, Examples, Basics, and then Blink, which will pull up this code. And then do you have your board? Yes, your board is plugged in, right? So then you go to Tools, Board, and you should see Arduino Uno as one of the options. And then go down to Port and click whatever the highest number you see there is. So you should see, you might only see one or you might see a couple, but just click the highest number. And then once you're done with that, click Upload, which is under Edit. It's a little arrow.
Just a question, but why do some people see a lot of ports and some people don't?
Yeah, so it essentially depends on like some random, like if you've configured things on your computer before, or if you've used a bunch of Arduinos, or like have a bunch of random things plugged in that for whatever reason have COM ports. So I actually used to have like some fake serial ports on my computer, and they would all show up that I was actually using for a Rocket Club project where I was testing something that was like an Arduino. So I'd have like, when I go to tools ports, I'd see like COM 8, 9, 7, and then like whatever one the Arduino was. So it might have been 3, it might have been 9, it might have been 10 or something. Also, funny thing, on Windows, COM ports start at 1. On Linux, they start at 0. So, or any Unix thing. So Mac OS starts at 0.
Can I send you or Ben my error messages?
Yeah, Ben, are you okay to have those sent to you? Just send it to Ben and John in case one of them isn't here.
I just messaged Ben and he hasn't responded. I'll send it. I'll harass John now.
Okay, then going down to the next one, Quinn. So yours still isn't working, right? Quinn, so yours still isn't working, right?
Yes, it's still not working. I have the correct programmer, but it's still not responding. And I just tried it again after unplugging, plugging it back in, and then pressing a button reset.
So what kind of cable are you using? Where'd you get that cable?
I got it from Tyler.
Yeah, that's one of the ones that I gave out.
Are you sure it's not a power only?
No, well, because it's working for a few other people in the car right now.
Okay.
I'm using a cable from a graphing calculator, which I assume you should be able to program.
Yeah, no, that should be in.
That should be fine. Yeah, because you can usually the graphing calculator ones you can program them. With any cable.
Are you on Windows machines?
I'm on a Windows right now.
All right, so if you go to Device Manager, you search Device Manager.
Yeah.
I'm also going to follow along with you guys. Sorry
And
for everyone
go
who's already has this
to-
working, but we'll get to more stuff soon.
Oh crap! I guess it doesn't show up.
Ports common LPT or?
Ports, yep.
Yeah.
Oh,
And you
ports
should-
common LPT. Yep, you should see it. It's a USB serial port.
Oh, I did not see that.
That's why.
I have.
Let me try. I'll try. Sorry.
I have serial over Bluetooth link for my ports.
That's it?
Well, I have ports and then common LPT, and then I have standard serial over Bluetooth link COM4, and then same thing COM5.
Oh, okay.
You should see USB serial port. That's the only one that will actually mean it's connected.
I can't zoom in, so I don't know if you can see this, but I'm showing it on my screen.
I'm gonna try a different USB port on my computer then.
Yeah, try that first. Sometimes that's the problem.
Okay, so David, did it work with the other pin for you, the other LED?
I tried with LED_7. I think that's what Matt said, if I remembered right.
No, just the number 7.
Oh, that's why. All right.
Literally just 7. Yes.
Okay. 7.
But are you able? Does it like say done uploading, and does that stuff all work, or?
Yeah, I just tried with 7. It uploaded, but it's not flashing anything.
Okay, and then the last one I think was Trey. What problems are you running into right now?
It seems that the driver is not properly installed, even though like my red board works okay.
Well, this should be a different. This should just be like a standard driver. So, did you go to the device manager?
Yeah, I'm there right now.
Are you seeing USB serial port or no?
It's under Universal Serial Bus Controllers, like all the way at the bottom.
No, it should be under common LPT.
Yeah, it should be under ports, common LPT. If it's not there, then there's probably a problem with the board.
Yeah, it's not there at all.
All right. Should I do like a breakout for?
Yeah. So if you four, so Emma, Ethan, Trey, and David, I'm gonna put you in a breakout room with Ben.
Can I join that one as well if this is for
Oh, Quinn.
connection
Sorry,
help?
I forgot. Wait, Ethan, yours is working, right?
Yeah, I'm
Yeah.
good.
Sorry, got Quinn and Ethan mixed up. They swapped spots on my screen.
You can stick me in that too.
Okay. Okay, so now you guys should have the ability to go join the breakout room. Okay, cool. So we're gonna keep moving along, and we'll get back to catching them up later. So the next step is, so what you should do is go into Arduino, and we're gonna change, see where it says delay, change it to 500 instead of 1,000, and then re-upload your code. And if you look at the LED now, it should be blinking twice as fast. So essentially what you did there is you made the delay half as long as it was before. So instead of waiting a second, you're now waiting half a second. This measures in milliseconds. Yep. Does that work for everybody? Looks like it did.
Yeah.
Cool. Okay. So that means we have finished testing the board. Your guys' board seem to all be working. So that's cool. That means you soldered it correctly and didn't mess anything up. And we didn't mess anything up because I don't think we actually tested all of, we couldn't have tested all of these FTDI chips before. So we might have a problem there. Yep, so we already did that. Okay. So I'm going to start just quick. So this is essentially the reference page for everything Arduino. It has all kinds of fun stuff. So all the different functions you can use, and if you click on them, you get you get like actual documentation on what each of the different, I'm gonna zoom in because I need to remember that I'm doing this on a big monitor. So you get like, you get different information about it. So then you can do like here where you can check like, oh, these are the different time functions. So we have delay, which pauses the code for a set number of milliseconds. You can get milliseconds, so millis, and this will give you the current time in milliseconds from when the board turned on. And you can get microseconds. So a microsecond is 1,000th of a millisecond, I think. I think it's a yeah. Yes, times 10 to the negative 6 seconds. Millionth of a second. So that's some of the different functions you have here. I'm not going to go through like every single one specifically, but you can use this page as a reference if you're trying to do something. I'll talk about a couple things in more specific detail when we look at the actual code in Arduino. So then you also have how variables work. So you have different data types that you can use. If you haven't done any programming before, send me a message and we will, like, just real basic stuff. Like if you've ever do you know what a data type variable is, that kind of thing, and I'll find a tutorial and help you with that. But in general, some of the important things to see here was like that you might not have heard of before. So const is a constant qualifier for a variable. So essentially what that means is if you use const, you can't change it ever. So it's really useful when you're doing things like saying, these are the pins I'm going to use. I'm going to use pins 6, 7, and 8, and you declare them as like constants. So they can't get changed somewhere else in the code, and you can't mess with yourself. Some specific constants built into the code are high and low, input, output, input, pull up. So these are all different constants that Arduino has to help you do different things, kind of. So we look through here. So like you saw LED built in on the blink code. So LED built in is a constant that is essentially just saying 13 for pin 13. Yep. So then I'll talk about how the sketches work when we get into that, but it also has all of these different things that you can do for like different parts of the code. So you have while loops, you have for loops, you have if statements, you have switch statements, you have pound includes and pound defines, which I'll show a little bit of. You have comments. You have to end every line with a semicolon, so it's just like C or C++ or Java. In that respect, you have a bunch of different operators, but you kind of just like, you'll look this up when you need to do something with them, is kind of how this is normally used. So yeah, so Arduino is technically C++, but it kind of doesn't make you deal with some of the more annoying parts of C++ if you don't want to. Or, yeah. So then I'm just going to start by going through what Blink does, because this is a pretty straightforward example. If you guys want to unplug your boards, feel free to now. You don't need to like leave them plugged in all the time. It's not going to hurt anything if you do, but I don't know. I get a little paranoid about it. So yeah, so the generally how Arduinos work is you have these two different functions. You have setup and loop. So setup performs a whole bunch of like configuration options when you start running code. Emma, is your board working?
Yeah, it was a chord error.
Your cord was bad?
Yeah, my brother gave me a different cord and it's working now. So.
Oh no, that's concerning for the other people who are over there, but okay. Because I don't have more cords.
I'm pretty sure mine's a calculator charger, but I could have also just found it somewhere else in my house. So.
Cool. So I will just. So you're in Cornerstone, right?
Yeah.
How far have you guys got with Arduinos so far?
We've done like the first couple assignments. I've fooled around with it a little bit, but I like.
Okay.
I've kind of just picked it up from what I know from C++ and then like trial and errored it.
Okay, so I'll just show you real quick. Here's a page that has a bunch of different reference pages. So it's just, I'll copy it into the chat for everybody. If I can find the chat. Oh, there's the chat. Oh, Matt already found the buzzer, apparently. I didn't see that message earlier.
Very annoying. Would not recommend.
So there is the reference page that has a whole bunch of cool, like, different things you can look into for different functions that you have available.
Okay.
And yeah. But now we're looking at Arduino. So so you've definitely seen setup and loop. That's kind of what I'm talking about generally right now. For people who haven't used Arduino before, setup is where you initialize things. So like right here, you're telling this pin, LED built in, that it is an output. So your LED is an output pin, so the board is going to send signals out of that pin. And then what you're doing in the loop is you are writing that pin, LED built in, and you tell it to go high. So you tell it to turn on. And then you wait for 500 milliseconds, and then you tell that same pin, okay, now it's low. And that causes it to turn on and then turn off. And that's what you see when you're running it on the board. Okay. So now I'm going to go to another example, just because this will be pretty good to show. I'm going to go to software. I think this is the right one. This might actually have what I want. Oh yeah, serial call response is good. So this is another really useful tool when you have Arduinos like powered over USB ports. And this is how I've got myself into a ton of trouble before. So you have a serial connection with the Arduino, which is very handy and very easy to use. So if you do this code right here, serial.begin, and then you use this while loop, while I can't say that word today. While not serial, do nothing. So that means that you're going to wait until the serial port is connected, and that is serial through your USB port. So serial is essentially just saying it's sending messages back and forth over the USB port. And then what you can do is you can, in your loop, I don't know why there's so much code in this thing. In this loop, what you can do is you can do serial dot something. So you can do serial dot print or serial dot println, which is another useful one. So that it prints a value and then does a new line afterwards. And you can say something like, we're just going to make this real simple. You got to do hello world, and I spelled hello wrong. There we go. That's better. I don't know what this established contact is doing, so I'm just going to ignore all of this stuff because I don't really care. And then I'm going to plug in my board. I'm going to also add a delay. So this doesn't print constantly. So then upload it to the board. And if everything works correctly, if we go to Tools, and then Serial Monitor is a very useful tool. So if you pull this up, you should be getting Hello World coming through repeatedly on your serial monitor. And this is how I've done 99% of my Arduino debugging, is just like, it's not working. What do we do? Print some stuff. And then the biggest errors I've ever had were the print isn't working. And that's when you know if problems are real.
What is this example called again?
Oh, it's serial call response.
Do you know, is it under communication? There we go. Okay.
Yeah. It doesn't actually do what I wanted, but I deleted a bunch of random stuff to get it to this point. And so if you ever see like random characters on this screen, this is usually what the problem is, and it's not gonna, I'm sorry if you guys can't see what I'm doing, but I realized that my screen is higher resolution, so it might look weird. But this baud rate over here, if it's a different number, so let's just change to this number, you'll notice like it just shows up as a bunch of question marks and random characters and stuff. So that is essentially how fast it's sending the characters over the wire. And if it is expecting them faster than what you're actually sending, you'll get random junk. And if we go back to 9600, it looks right. And if we go like down to 4800, it's also broken. And that is the number that you define right here. So if we set this to 4800, Now it doesn't work with 9600, but if you go 4800, it works. I'm actually curious. What happens if I go 300? I've never done this before. Is it gonna like slowly come across the screen? Oh yeah, it does. It does. It's slow enough now that you can see the characters getting printed. Oh, that's fun. Way more excited about this than I should be. Okay, that's enough messing with cereal. I don't want to bore you guys too much with it, but I enjoy cereal stuff. I've spent more time in my life working with this than I really should have. Okay. So the next thing I'm going to cover is analog. So on your board, you have a set of analog pins, A0 through A5. So if you go to examples, analog, and then I think analog input. Yes. So what you can do with analog pins is you don't have to define a pin mode when you're using an analog pin. You only need to define pin mode for digital pins. And essentially, the main thing you're going to use with analog pins is you can do this analog read and then a pin. So in this case, sensor pin is A0. And then what you can do is, so what this is doing right now is it has a sensor attached, which we don't have, so you can't really run this code. It won't do anything. But it's delaying for a different amount of time based on what the voltage is on that analog pin. So the way an analog pin that works is it reads. I'm not going to get into how ADCs work, but essentially there's this thing inside the chip called an analog to digital converter that takes an analog voltage, which varies from 0 to however many volts you can have, and it converts it to digital, to a number, to a digital signal. I think it's cool, but so again, I'm a nerd about this stuff. But yeah, so that is essentially how that works. That's how analog read works.
So that's like, it's reading based off the voltage, whether it wants the light on or off?
Not quite. So it's reading based on the voltage, how long to have the light on or off for. So the same thing as like the blink you were doing earlier, based on the voltage it has, it would change how long those delays were. Then I'm going to show you guys one more. Let's do what I want it to do. Yes, this has the last part of code that you need to know for what my little task is. We'll see how well this works. But this is digital read. So in addition to digital write, you also have a digital read, which essentially reads whether a pin is high or low. So in this case, it has a button that's connected to this digital pin number 2. And when you press the button, this will read as 1, and when the button isn't pressed, it will read as 0. So if the sensor value is high or 1, it turns off the LED. So that means whenever you hold the button down, the LED goes off. But we don't have the button, so we're going to have to find another way to do something like this. So, Trey, did you get your board working?
No, I didn't actually. I tried restarting my computer, but it did not work.
Okay. So I think what I'm going to have you and the rest of the people from over there do is just watch this section of the lecture of the recording. I'll put timestamps up for what I was just talking about. Does anyone have any questions about basic Arduino stuff? I hope it wasn't too confusing.
Will you repeat the what you just said about the digital stuff?
Yes. So we had digital write that we used earlier to send out the signal to the LED. So that's what like turn the LED on and off. So you also have digital read. So what digital read does is it uses that same pin, but it goes the other direction. So you have to do it as a, don't worry about it, pull up, but you can define it as an input for the digital pin. And then you can read it. So when you read that pin, if it's high, so if the pin is above a certain voltage where it's considered like it's a high pin, then it will read a 1 or the high constant.
Do
Or
you
if
have
it's
to define whether like where the cutoff before high and low is, or is that
no,
automatically?
so
in
that
Arduino?
is
Is it just a 1 or a 0?
yeah, it just gives a
Okay.
1 or a 0. But there is actually some cool. I'm just gonna show you guys this logic level tutorial. Yes. So this is essentially how that works. So you have these different like ranges that you'll read different things on for high and low. So for 5 volts from 2 to 5 volts, you're going to read a high voltage. And then from 0.8 to 0 volts, you'll read 0 or low. So that's kind of, I'll send this tutorial to you guys. I found this really interesting when I first looked into it. But there's like different ranges that you can get for different, for digital logic. So for high and low voltages, which is pretty cool. But that doesn't actually really matter. So I do have a challenge. So you should have a little spool of wire in your kit of electronics. And you should also have some wire strippers, I think. I'm not entirely sure, but if you don't have those, you can do this with a spare resistor from your kit. I tested that too. So I mean, you might want to just use a spare resistor if it's easier. And it doesn't matter which resistor you use. So what you need, what I'm going to have you guys do is connect 2 of the pins on your board together using a wire or resistor. So connect an analog pin and then one of your digital pins. And did I show you guys analog write? I don't know if I did.
I don't think so.
Well, so in addition to analog read, you also have analog write, which is just the same thing, but you add a value to this. So say, and it goes from 0 to 255. So like 100 here. And depending on that, it doesn't actually, but we're just going to say for now it outputs a different voltage depending on that. That's what we're going to say for now. It's not actually true, but it's close enough for what we need. So that's how analog write works. So what the challenge is for you guys to try to do is to connect those 2 pins together using an analog pin that's writing out a signal and a digital pin that's reading a signal, and try to figure out what, I'm going to give you the equation for voltage on this slide, but try to figure out what voltage it takes for the digital pin to read as true. This shouldn't be too hard. I did it earlier, so, and I think the equation is I will look at the Arduino reference for analog write. Value. is the correct term for that phrase. Oh no, this looks all weird now.
I use like a spark phone jumper wire instead of splitting or stripping the wire.
Oh yeah, if you have a jumper wire, it's probably easier.
Okay.
It also works with a resistor, I think. But I guess the resistors aren't long enough. Yeah, you probably would want to use a jumper wire. Voltage.
And there's no way I can possibly short it, right?
You should be fine. So there, I just sent it here. I'm also going to send it to the chat. That is the equation for voltage when you're reading it, when you're outputting from the analog pin, roughly. I don't know, John's going to hate me for doing this. I kind of glanced over this PWM, John, but it works, so.
Okay.
Yeah. So if you guys have any questions while you're doing this, just let me know, and I will do my best to help you without actually giving away the answer.
So we're reading the value from the analog pin using the digital pin?
Yes.
Okay.
So you can output different values from the analog pin, and then you're trying to figure out what the value is when we're trying to figure out what the value is when the digital pin goes from reading low to reading high. And it just returns, low is just 0 and high is just 1. So you'll see that it's pretty straightforward to tell what that is. Okay. I'm also going to copy the link to the slideshow so I can stop screen sharing. Okay, David, did you get your board working?
No, I didn't. We're just gonna like meet up and try to look over it in person because we can figure out what was wrong with it.
Okay, and I'm gonna guess that the same for Trey too.
Is he back?
Yeah.
Oh well, we didn't plan anything because I left, but I mean I'm on campus too, so I can.
Yeah, Tulasi. So you're just connecting. So you can define the pins however you want in Arduino. So you just need to pick one of the analog, so A pins, it says on the board, and then one of the digital pins, which should just have numbers next to them. And then the wire, there should be a little spool of wire in your kit. Yep, like that. And then you can cut a little section off using, I think there's wire strippers in the kit. I'm not sure. So those are snips. So you can probably do it with the snips, but there might also be actual wire strippers. Yeah, is it just the snips? Oh, there's like, it's like a yellow handle. That thing, yes. Oh, I bet it's, oh no, I bet it's stranded wire, isn't it? It's not solid core. Oh no, okay, well, hopefully this works. Oh, maybe I should have done that. Maybe I should make some progress on Quinn's. Yes, Ethan, that's the right wire. You just need to cut a little section of it off.
How does the digital read, like parentheses, work?
Yes, so digital read, so you have to define the pin as an input. So that whole pin mode thing, instead of output, you'd say input. And then, so you have a variable. So however you want to define that, if you want to do it there, so you can just do like int the whatever thing equals. So you just say something equals the digital read.
24 would be, so your analog's your output?
Yes.
And is and
how do you unupload a file to your Arduino board?
just unplug it.
Wait, upload a file?
Unupload it.
So yeah, it's the same way that you uploaded the Blink program earlier. Just when you're like writing it, if you click the upload button, which is underneath edit at the top of the program.
Yeah, so the thing is that I did that to like a random file. And like now it's like my LED is not turned on anymore. And I have like my buzzer.
Just unplug it and plug it back in, I think.
Yeah.
That's what I did. It's still doing the same thing.
It's not, you can't like remove a program from the board. You just program a new thing on there.
Yeah, just re-upload the Blink one.
Okay. Also, like if I upload another one, it's like if it overrides it.
Yeah.
Yeah.
Gotcha.
So whoever didn't hear this the last time who was here, if you were in the other room, this video will be uploaded. I will send the link and the timestamps for where I talked about Arduino, so you can watch that later when your board works. Yeah. This was bound to happen, but I feel kind of bad about it.
Sorry, can you pull up the slide with the like prompt thing again?
Oh, yep. I will share my screen with that again.
you explain the analog output code again?
Yes. So it's shown, it's actually up on the screen share right now. So when you do analog write, you give it a pin. So that would be like one of the A number pins. And then you give it a value. And that value is from 0 to 255. And depending on that value, it will output a different voltage.
Okay. If I share my code with you, will you tell me why my what's it called? Monitor isn't outputting anything?
Yeah. Yeah, you can just send either a screenshot of it or just send the INO file to me. And that goes for if anyone else wants to send me their code, I'll take a look at it.
I realize it was probably a bad way for me to take a screenshot, but if you want it bigger, let me know. Let me make sure. Oh wait, I may just have to. I may have the wrong numbers now that I look at it. I think I have a schematic issue.
What do you mean? Like the number should be printed on the board, right?
Oh, is it just those numbers, or do I have to look at the schematic?
No, just the numbers on the board should be fine.
Oh, so like A1?
Yep.
That might be my issue.
And then for digital, you don't have to put the D in front of it. I don't actually think it matters, but you don't have to put the D for the digital pins.
I'm actually not sure it would even work if you put D in front of it.
I feel like I've definitely done that before, and probably it hasn't worked, but I don't remember.
I changed it to A1 and 5, and it's still not working. So
Is it just not displaying anything on the serial, or?
yeah, it just says like COM6 is blank.
Yeah, you want to. That shouldn't make a difference for the serial. But
So you have a serial.begin thing, right?
I may not.
So you need serial.begin. Usually it says like 9600 is fine. And then make sure that when you're opening the serial monitor that it's set to the same thing. So 9600.
Yep. Has anyone figured it out yet or no?
Okay. No, I'm just gonna
I feel
get
like I kind of get what to put in the loop, but I don't really know how to do the setup. So I'm trying to figure that out.
Okay. If anyone wants, if people want to, I mean, I'll walk through it in a few minutes. I wanted to give you guys a chance to try and do it yourselves. But if you guys want me to walk through it, I'll walk through the code that I wrote.
How do I stop a loop in Arduino?
So you can't stop a loop. So you have the delay, so you can delay before you do the loop again. But otherwise you kind of just have to like reset the board and redo it.
Okay. How do you... I could be overcomplicating what you want me to do. Can an analog output an integer value for voltage?
Analog output?
Or analog write?
So that analog rate, it takes a value between 0 and 255, and then it does math on it on its own side to produce the actual voltage.
Yeah.
So it kind of outputs anywhere in between 0 and 5 volts based on that number. So that like that equation that I showed in the slideshow.
Yeah. But in the code, like I'm trying to set up so that like it's outputting. I'm running a loop where the output just increases by 1 each time. So do I declare an integer for the voltage in void setup? And then can I write that variable?
So what I did when I did it is I just used that variable that you're talking about that increases every time the loop runs.
Yeah.
And then I just calculated the voltage when the digital pin read. I just did the voltage calculation at the end. Do you see
I'm
what
just
I mean
getting
by
an,
that?
I think so. I'm just getting an error when I tried to upload my code that V, which is my voltage integer, was not declared when I tried to write it in.
I'm downloading your code.
I changed it. Wait, give me a sec. It's different now. I resent it.
Yep. Talasi, that's exactly, that's pretty much exactly what I was looking at. You don't actually even need to do the for loop for that, because you have the loop already.
Yeah, I wasn't really sure like how.
Well, what you'd want is you're going to want a delay between every time you write it, because it takes like a few milliseconds for the write to like actually propagate. Okay. I think I'm just going to walk through what I did. However, oh, John left. I didn't get to say bye, John. Sorry, John. Why is V? Oh, because you declared, Emma, you declared V inside of setup.
Oh, okay.
So you can declare V like above setup, and then it will be a global variable, and you can access it anywhere. But right now,
okay.
V, you can only use V in setup. Yep.
Gotcha.
Okay.
When I print stuff out, it just kind of prints like alternating ones and zeros.
Whoa, that's interesting.
So I've got a jumper connected between like D3 and D5, and I've got D3 set up to be like an analog PWM, I guess.
Yep.
I'm reading that, and I set the duty cycle to like 128, and it's 1010101010.
Oh, you're actually getting it. Okay.
Yeah, I'm getting ones and zeros.
And if I set it to 0, then I get 0. And if I set it to the pin to say
Okay,
to
so
2
you
to 5,
guys
I
are
get 1.
reading faster than I was reading. That is why you're getting that.
How do we slow down?
So you just add it. So I'll show you guys the code that I had now. If I even have the, yes, I definitely have the code.
The Arduino doesn't have a DAC.
No, but the way that it works is when you're doing an output of a PWM signal, it actually works right with the digital pin if you're reading like slow enough.
Yeah, you gotta add like a. I wouldn't have thought that it worked.
Yep, it worked. I don't know why it worked, but it worked.
I would have thought you need to add like a low pass filter or something.
Well, I'll show it working, which is kind of cool. So yep, sharing my screen again. So this is what I wrote. So I need to wire them up. So A0 and D7. Yeah, this would have been better if we'd put a DAC on here, but I didn't actually, or a, yes. But I didn't, I just thought of this off the top of my head when I was like, what are we gonna do today? Oh, that's something to do. So yeah, if you do read really quickly, it will just read ones and zeros because that's actually how it's working. But if you read with a delay, so I have a 500 millisecond delay. Hold on. Oh, I'm on 300 baud. Hello world. So it goes 0. I increased by 25 because I want to do it quickly. But you'll see when it gets to 150, it switches over to 1. And then, yeah, so I used to have code to print the voltage as well. But essentially, so what that's showing you is when you think of the maximum of the thing is 255. So if you do the math on 150 divided by 255, and then times 5, you get about 2.75 to 3 volts, which is about what it takes to switch from a digital pin from high to low. John, Matt, and Emma, were you guys just like reading without a delay?
Yes.
No, I had I even had like a 500 millisecond delay between each of my reads, and it was still.
And you were still getting.
Right. Yeah, and I've just it's literally just a jumper cable between 2 digital pins, right? I think so. Yeah. So it's like right now it's 11111001000001, and I've digital written 190. So interesting, indeed.
Huh. Okay, maybe it only works on my board, and maybe I was just wrong. But yeah. So that's what I had.
Okay, I'm gonna try to copy your code and see if it works.
Yes, I would be curious if it does. Where I use analog pin and digital pin, you can just use a 0 and 7 if you want to, or whatever your pins are. You don't have to do the. Hi, Carrie.
Good night.
Is Arduino used in industry at all, or is it just like an educational thing?
So it's built on C++, which is what is used in industry. And it's used for like quick and dirty prototyping. So a lot of engineers, like you will use Arduino in industry, but usually it's not on like production products. But like if you just need to make something work quickly, you'll throw an Arduino in there and just make it work. Oh. Matt, do you want to send me your code real quick? I want to see where you're getting this with.
Yeah, sure. And I put that in Excel and averaged it, and the average turned out to be very close to the number I was writing my analog pin, like 188 versus 190.
Wow.
So let me just put this in paste bin.
That's actually like kind of exciting. I did not expect that to work like that.
Paste bin is now Yeah, no, this is really interesting. Zoop.
Yeah, if a bunch of people have already left, if you guys don't have any more questions, feel free to leave. If you want to sit around and talk about this, I'm sure that me and Matt and probably Emma will be sitting here talking about how this works for a while.
Okay, yeah, I might head out because while I would much rather do this, Tetris calls me.
Yep, good
Gotta
luck
just
fundies.
make all of Tetris.
That is, what did my class do in fundies? I don't even remember what I did in fundies.
Yeah, I gotta go do Tetris too. It's not gonna be fun.
All right, thank you.
But yeah, thank you as well.
See you
for the help.
guys.
Good night.
Yeah, night. I mean, my code was right? I mean, like, it's literally 8 lines long.
Yeah.
Tyler, I'm running yours and I'm only getting ones.
Which pins did you jump?
1 and 5.
Shouldn't matter, right?
No, it really shouldn't. That's actually crazy. What?
One's a PWM pin?
Or I'm getting the integers or like but at wait.
Is the digital read only coming back with ones?
Yeah.
Wait, 1 and 5. So if I put this on 1, right, and then I change
Analog 1 or digital 1?
A1 and digital 5.
Okay.
Oh, I didn't try analog.
So the analog pins can output PWM
Faster, maybe? Analog right. Is analog right the function I use to set an analog pin? I don't remember. Set.
Ah, Molly, you're still here. Did you get it working, Molly, or
Yeah.
were you able to like get the oh, I have my chat up. Forget that I'm screen sharing all the time. That's kind of cool. So did you copy my code or did you have it yourself? Just curious.
In the end, I ended up copying yours.
But it worked.
Yeah.
Huh. Okay. So like it showed 0 till it got to like 150 and then it showed 1.
Yeah.
Oh, cool. Okay. My code worked. I thought my board might have just been wonky.
No, it worked.
Yeah, I think that was actually the difference. Is that I was using PWM on a digital pin, which was low enough frequency. Because if I changed, I just jumped analog pin and now it's working as I would expect. So I've got it here.
So
between.
I feel like
Yeah.
what we're actually getting here is something else than what I think we're getting here. Because I think what's happening is that analog output just isn't outputting until it gets over that minimum output voltage for digital pins.
What happened?
I'm guessing that pin just isn't PWM enabled and it's just not working right at all.
All right, well, let's see if I jump 2 analog pins together. Analog read one of them.
Yeah, I tried it again and I'm still getting. Wait, let me reset. Yeah, I'm still getting the ones for digital pin. Should I try a different pin to see if that's the issue?
Yeah. Like I used D7 and A0 when I was running it. Yeah, it'd be nice if these boards had an actual DAC on them. I'm going to break it out right now. When I was digging through for some supplies to find my old breadboard and make it work right, I found some of my teensies, which are, there's 3.6. They're essentially, it's working now?
Yeah.
Okay.
So something with the analog port, or I don't know what the right word is.
Interesting.
Embedded systems are magical.
My life is playing with the magic.
Does that make you a wizard?
Guess so. But so I don't know if have you ever heard of teensies, Matt?
I have heard of them. Of
Yeah.
them, yes, not what they are.
Okay, so I mean it's essentially an Arduino, but I'll pull it out of its little bag here. It's kind of like more like an Arduino Nano, where it's like designed to go onto a board with through holes. So like, there's the actual board.
Ooh, tiny. Yeah.
Yes, they are. Very, very mixed feelings within the club on these. The other Avionics lead, Adam. Well, you know Adam. But Emma probably hasn't met Adam.
No, I don't think so.
Yeah, so Adam's the DPF Avionics lead. So the other Avionics lead in the club. He hates these things with a passion. But what these have is they actually have, where is it?
Wait, one sec. I have a random red light on. Should I unplug it?
I found that if you jump pins that are also connected to the LEDs, the light will turn on.
Yep, pin 7 is connected to that LED.
Oh, okay.
But I don't know why it turns on. I just know that they're connected.
So this board, this teensy has an actual DAC, so digital to analog converter. So it can produce true analog signals.
Does the STM32 have a DAC?
I don't know.
Because I stole one.
Oh, you have one of those.
Yeah. The Nucleo board.
I'm just gonna go find mine. It'll be easier.
I could also Google it. That seems easier. Waveform generation. Whoa. Ooh, whoa. Yeah, it looks like it does have
It does have a DAC?
It has waveform generation stuff anyways.
Yeah, that's probably right. Huh. I'm gonna have to dig for this. I don't remember which box I put it in. Yeah, but I think what's actually happening with that analog pin is it just isn't outputting until you get over whatever the minimum threshold voltage for digital is, which would be actually producing the right digital voltage, because for some reason they just happen to it would just line up like that.
Where's my multimeter?
Because when I was testing with a multimeter, it wasn't working. Like it just would display 0 volts until it hit that. That's what's happening. Okay. So it does work. It gets you the right voltage. It just does it in a way that isn't technically correct. But yeah, these teensies are a lot of fun. I love working with these little things. Look, I mean, just look at so like this is a reference card. Look at how many different things each of the pins can do.
Whoa. Is it, what's the processor? Is it an ARM thing? Processor, or do you know?
I don't remember. No, and it has pins on the back too.
Oh, whoa.
There's like surface mount pins on the back.
What? Insane.
They're not really useful once we get to using the actual STM chips, but you can program with an Arduino.
Oh, Arduino. Okay, that's nice.
Yeah.
Oh yeah, I get to melt things this weekend, hopefully.
So that thing you have. Oh wait, did Andy actually find the nichrome wire?
Yeah.
Oh,
24
awesome.
TA.
Oh, did he buy new ones?
No, I don't know. He just showed up to my door and was like, "Hey, I got your wire. Come outside."
Okay. Yeah. So that board that you're designing right there is actually something that me and Scott didn't exactly work on at work, but we kind of know vaguely what's going on with how that's supposed to work.
Well, there's a white paper somewhere.
Yes,
also,
Scott, the person from Scott's
Scott,
work who actually
yes.
worked on it, gave Scott that white paper, and it was like, you can say anything that's in this white paper.
It's amazing. Yeah, no. So it's basically nichrome wire, go burr, and it should slice through like a nylon rope.
Yep.
Spring.
I will say that when nichrome's used correctly, it's very reliable.
Yeah, it's the using it correctly part that's going to be interesting.
Yeah, I mean, really, you just need to figure out your resistance on that, and then figure out what you want your constant current to be.
I don't know what my current needs are going to be, but I'm going to buy some AA batteries and figure it out.
See how it works.
Because I've got the reference, like I know how many ohms per meter it should be.
Yeah. I mean, you can also test it with a multimeter.
I can do that too. I think, was there one in the intro kit?
Yep.
Yeah, there is.
I don't know how reliable that one is, but it should work.
Should have brought my fluke. The one that my mom stole from work like 20 years ago. Nice.
This is the cheapest fluke you can buy, but when my old multimeter died, I'm like, you know what? I'm buying a fluke. They are the nicest piece of hardware on the planet. I'm buying a fluke.
I assume it's been nice.
Yeah, I like it. I mean, it's really simple. Like, legit, this thing has AC, DC voltage, current, resistance, diode check, and then that's it.
I wonder if I'm going to melt my plastic mount testing this. I bet I will. It'll be fun.
I have no idea
Yeah.
what you're talking about, so I'm gonna head out.
Oh.
It sounds interesting.
Yes. No, it's interesting. It's in the. I don't know if you're
Matt
doing-
is already involved in 3/4 of this club's projects.
I am.
Yeah, you
Well-
seemed ahead.
Sorry. Yeah. No.
That's all right.
I got.
I'm
bored.
interested in it. I
Yeah.
just
Yeah. No, it's super cool stuff.
baseline knowledge I have is much lower than yours.
Well,
Well,
we're gonna get you guys working on, like, I'm hoping we're gonna get quite a few people out of this group to, like, actually work on stuff soon.
Yeah, I'm excited too. I just know nothing.
Yeah.
nothing yet.
That's the hard part. I mean, I knew nothing. I had never even used an Arduino when I came to college.
Yeah, same.
And then by the end of my first semester, I was the Arduino expert in Aero and U, and that was scary.
Did you come in as CE or CS?
CE. And then I was too lazy to do the CECS. So I just
I
didn't.
feel like everyone who was in CECS regrets it and goes to CS. It was like, I wish I was just a CS major.
Yeah, no, I actually like being a CEC with a CS minor. I like the CE classes because I don't know, I like hardware. I think life would be boring if I only worked on software.
Yeah, this is making me kind of interested in electrical engineering as a major.
What's your major right now?
Civil or environmental?
Oh, nice.
But
Yeah.
I want like a more hands-on like type.
If you want to like actually work hands-on with stuff, Mechie and EE are going to be the most. Like more than CE, more than CS, more than Civi, like those two.
Yeah, the
for
appeal of
sure.
Civi was maybe working outside sometimes.
That is true. I will say though, there is the possibility in EE or CE, like if you get in the right industry, you can work outside. It's just usually when you're working outside, you're very stressed because you're like, at my company, we'd do flight tests. So they'd go out in a field and fly the thing we were working on. And
hope it works.
And hope it worked.
Yeah. Yeah, right now I'm leaning towards switching to EE, but that could change in a month or two.
Yeah.
Or a week.
How much hardware is in CE?
So let me think. So I take the same classes as EE for the first few. So both EE and CE have to take embedded and circuits, which are kind of like the first classes to both, which were both awesome classes. Probably like after computer systems, like two of the most useful classes I've taken. In the circuits class, we built a working EKG machine.
Yeah, someone told me about that.
We read my partner's heart like signals through like an oscilloscope. It was awesome.
Whoa.
Yeah. And then in embedded, like you build like a robot arm. Like you control a robot arm to pick things up and move them. So EEs and CEs both take both of those. And then CEs, so you have computer engineering fundamentals and electrical engineering fundamentals. And so CEs take all of the CE fundamentals and one of the EE fundamentals. And then EEs take all of the EE fundamentals and one of the CE ones. And then there's ECE, which does all of both. And then you have tech electives. So technical electives, you have 4 of them, and you can do them in whatever you want. And you can also do 2 of them cross-counting with the CS department. So my tech electives are one I'm in now, which is computer organization, computer architecture. And then the other one is going to be microprocessor-based design. So these kind of things. Actually, it's more like the STM boards. And then my other 2 are CS classes.
Yeah, it seems like electrical had more flexibility than some of the engineering majors. Like you kind of took the fundamentals and then kind of branched off to what you wanted to do.
CE and EE have way more flexibility. Mechie has 1 tech elective.
Yeah, civil has a few, almost.
Let me look it up. I honestly haven't looked up civil engineering.
Do you take, I don't know, you guys all take like GE 1501, right?
Yeah.
I don't know.
What's your major right now?
I'm Mechie right now, but I like electronics and mostly software too much. So I don't know what I want to do.
Yeah, so civies get 3 tech electives.
Yeah.
That's nice.
And you get a project elective. Okay, that's kind of cool. Oh, so you get to pick if you want to do water treatment, foundation engineering, highway design, or hydraulic.
Yeah, there's like concentration areas and stuff.
Okay, so Civi is interesting, for sure. That's my biggest gripe with the Mechie department is they just pigeonhole you so much into like you have 1 elective.
Yeah.
Like 1 tech elective.
Right. I mean, I guess you do get like you can choose like a minor, and I think you can count like new path stuff towards a minor, but it's not quite the same.
And technically you do have a few more credits. Like you could take more mechanical engineering classes if you wanted to. But the thing is with Mechie you get such a breadth because you do an EE class, you do material science, you do statics, mechanics of materials, thermodynamics, fluids, measurements, FEA, mechie design, systems, heat transfer. Like, there's just a lot of
There's a lot of stuff. It's going to be an interesting 4 years.
yeah. So I mean, most of my friends are mechies.
Well,
But
most of the engineering school is mechies.
yeah, also most of the club is mechies.
Yeah.
I don't know.
Have you heard anything about mechatronics at all? I don't know.
As what?
As I think there was a minor
It's a-
and also a concentration in your major.
It's
Or
a
master's,
grad.
sorry.
It's a grad. Yeah,
Grad thing.
you can do a master's in mechatronics.
Masters, yeah. I don't know. I just saw that and I'm like, huh, that's interesting. I wonder if anyone's heard of that.
You can do a robotics minor.
You can also do a robotics minor. But I don't remember what.
But that's a really hard minor to do, especially as a. Oh, that's in the ECE department.
Oh, it is. Robotics, dynamics, and control.
That the
I
Mech
take
EE class.
Energy 10 and embedded design.
Or
Or I would take embedded design.
well, you have to take EE if you're a mechie.
Right.
Actually, I don't think you can take embedded actually. So you're not supposed to be able to take embedded design if you're not an ECE major or a CS major. But if you talk to the advisors, you can get around that requirement. I actually know someone who took it who was a mechie.
Okay, so that's kind of interesting.
Yeah, I don't know. I'm going to be biased. I'm going to tell you guys to do EE or CE because there's some issues with the department, but I don't know. I think it's cool.
Yeah, I don't know.
I also
nervous.
like learning more. Like I don't know. I learn more on co-op and in clubs anyway, so I might as well take the technically slightly easier classes. Like CE is definitely easier than a mechie degree. Like it's not. It maybe some people really struggle with it, but it's definitely easier than a mechie degree. Like there's nowhere near the grade struggle that there is with a mechie degree. Like some of the classes are really hard.
Oh no. Oh no.
Yeah, no, I had an iffy experience with E&M in high school, which is why I'm a little hesitant. But I'm just telling myself it was because school closed in March, right as we were getting to circuits.
Yeah, are you taking Physics 2 now or next semester?
No, I'm just in Chem, and then I have credit for Physics 1.
So then you'll go into Physics 2.
Yeah, so I'm a little nervous about that. Because I was hoping to test out of it, but not with COVID and not having physics for 2 months.
That's not. When do you have to decide your major by? I don't remember when it was.
I think end of freshman year.
Yeah, because I think you pick classes in like March or April.
Yeah.
Yeah.
You're not even allowed to declare until spring.
Yeah.
I don't think.
You also get your co-op cycle, I think, in February.
Yeah.
I think that's true.
Yep.
Did you take Physics 2 at Northeastern, or did you?
Yeah, I
decide
did.
it?
I took it in the spring. Yeah, because I had
How
Physics
is
1
it?
credit. I don't know. I had taken E&M, didn't pass the exam.
Okay, that's the boat I was in.
Yeah. I don't know. It wasn't bad. It wasn't.
And you were
the lab
fine as
reports
it-
were the worst part.
Yeah. And you're fine as in EE classes if it wasn't totally your thing.
I'm not huge on circuits, but that, I mean, I'm a CE, so I only had to take that one circuits class. I didn't have to take the other EE classes.
Gotcha.
Which are, what are the other ones? I'm taking electronics right now. And then there's linear systems and electromagnetics are the other two.
Linear system sounds fun.
Matt, why are you a mechie?
I don't know. I don't know. Have you heard of FIRST Robotics?
Yeah, I mean, I did first too.
Oh yeah, I wrote like half the state space stuff that got merged this summer.
Yeah, I don't even know what you're talking about. We wrote code in LabVIEW.
DAVView.
Oh.
Yeah, I don't know why I'm a mechie.
Emma, it's a block programming language.
Oh,
have little blocks and you draw lines between them, and that's how you program it.
I hate block coding.
Yep. I was the master of LabVIEW. I'd like run around the pits at the events, Matt, and like any team that had LabVIEW, there was always like a couple rookie teams that had LabVIEW at all the events, and I just go and fix their code for them.
Very nice.
I think I was the only person there that knew how it worked.
I looked at LabVIEW earlier this semester and I was like, what is this? I literally couldn't see the blocks. They were too tiny and I gave up.
Oh. Yeah. I don't know. I will say that my ECE experience would have been much better were it not for two professors that just didn't know how to teach.
That's
I had my professor for fundamentals of networks and my professor for fundamentals of engineering algorithms were both terrible. They did not know how to teach at all. Every other class had good professors, but those two were just terrible. Wow. Wait, LabVIEW's really gone down that much that quickly?
It's aggressively declined in recent years, unfortunately, or fortunately, depending on your point of view.
What's crazy is it's pretty much entirely Java.
86%, something insane like that. And C++ is steady around 10.
Yeah. I wanted to do C++.
Good choice. Good choice.
But we just didn't have the time. Because I was team captain and doing prototyping and doing like building things and writing the code. So I was also applying for grants and like writing the whatever Woody Flowers Award papers and
Eek, indeed.
Yep. Okay.
Indeed. All right.
If you guys have questions about classes, feel free to. Where's probably the best place? Just drop it in like aerospace and new, like I don't know.
General memes.
Memes, off topic. I don't know. Helping questions. And, yeah. You'll get the Mechie spam because pretty much everyone you see is a Mechie.
How big is the Avionics group in the like DPF?
Like 8 to 9 people, probably.
Oh, okay.
I'd say probably 6 of them actually do any work because I don't do anything. I just kind of sit there and say some random stuff when I feel like it.
Yeah, I need to. Yeah.
Yeah, no. Matt is that ground station, Matt. I don't know if you have any clue how long that's been in progress.
I have no idea. None.
That has been in progress since my freshman year.
What year are you in?
4th.
What? That took like 2 weeks of not doing homework.
Yeah, no. Like, I looked at it a little bit. I didn't know what any of the stuff meant, so I never really dug into it. But, like, they were working on it back then. Yeah.
Long-term projects.
That was back, I was messing around with radio modules back then. That was what I was doing and being very confused.
Hopefully, yeah. They still haven't figured out radio stuff.
Yeah, no. Ben's made some progress.
That's good.
Yeah.
I still need to. Yeah, right now we're visualizing way too much data, and it kills the browser.
Yeah. Okay. Well, I'll let you guys go. If you have questions, feel free to reach out. We'll have to get you on DPF soon, Emma. We'll find a way.
Yeah, I'm excited.
Why not?
See ya.
Night.